Hi there, my name is Ian Glish, and this is my presentation on worldwide coral distribution analysis, examining the variables that affect coral presence in over 50 seas. The dataset I chose to analyze was on worldwide coral distribution and was sourced from Kaggle. It included data from 50 seas across Europe, Asia, Africa, Australia, and Antarctica, observing coral presence and other characteristics of those seas. Each sea had 49 observations recorded within its boundaries and 8 variables describing them. Both hard and soft coral habitats were observed, but the dataset didn't specify the type, referring to them collectively as just coral. The purpose of this analysis is to identify the conditions that support coral presence in seas, regardless of their geographic location. I focused on coral presence and absence as a key variable while examining other variables. My insights focus on which variables most support coral presence. This can help identify seas not included in the dataset that could be conducive to coral's presence and could potentially discover new species or have other new insights made. The original dataset consisted of 2,451 rows by 10 columns. I modified it to 2,450 rows by 18 columns by removing a row for a sea that only had one observation and by adding 8 columns through feature engineering to improve understanding and to derive additional insights. Potential outliers were retained and acknowledged as either extreme values, possible input errors, or recording errors. I wanted to start my analysis by looking at the breakdown of the types of seas and their amounts in the dataset, with a focus on the presence of coral. Marginal seas by far in terms of prevalence and coral presence made up the large majority, with partly enclosed seas coming in second place. Enclosed landlocked seas made up a very small proportion of sea types and had no coral presence. To find the salinity preferences of coral, I looked at the distribution of recorded salinities, which ranged from 5 to 40 PSU. Coral was highly present in the higher end of the observed range at 31 to 40 PSU, with a preference specifically for 34 PSU, indicating that coral presence requires higher salinities. This scatterplot looks at the correlation between June and January seawater temperatures, focusing on coral presence. A positive correlation exists between June and January temperatures for seas with or without coral. Corals are mostly found in seas with warmer January temperatures above 51 degrees Fahrenheit, coinciding with proportionally warmer June temperatures. Looking at the seasonal seawater temperature variations as it pertains to coral presence, I calculated the temperature difference between June and January seawater temperature. This visualization shows that corals are found across a wide range of temperatures, but they very clearly show a strong preference for very constant water temperatures. The highest number of observations is where the seasonal temperature variations is 0 degrees Fahrenheit, showing that corals thrive in seas where the temperature is consistent year-round. Silt and sulfide are both threats to the health of coral and can come from both natural and man-made sources. Looking at the number of types of seas with a focus on silt and sulfide presence, the visualization shows that overall each type of sea were heavily absent of silt and sulfide. Partially enclosed and marginal seas had very small numbers with those threats present. This visualization looks at the relationship between sea area and the presence of silt and sulfide. My initial thought was that smaller seas might have higher likelihood of silt and sulfide presence due to the smaller area to disperse them, but this doesn't show that. The black and yellow seas, both seas with low, moderate areas, had silt and sulfide present. This shows that other variables have more of an influence on silt and sulfide presence. This last visualization looks at the same sea area bar graph, but with a focus on coral presence. Specifically looking at the black and yellow seas, coral is absent from both, showing that silt and sulfide is a major factor to this absence, but not the only one, as there are 5 other seas with coral absence. In summary, coral presence was most prevalent in marginal seas, but was also present in partly enclosed seas. They favored areas with very stable temperatures, particularly warmer ranges, and higher salinity in the range of 31 to 40 psu. Additionally, they were present in seas with an absence of silt and sulfide. The strongest factors influencing coral presence were type of sea, temperature stability, and salinity. For next steps, I would suggest expanding the data set to include additional seas and new areas to help enrich the insights I've made. I would also suggest adding new variable columns for depth of sea, depths of coral, coral type, meaning if the coral is hard or soft, and photosynthetic ability, meaning if the coral is photosynthetic or not. These additional variable column data could help determine species-specific conditions and locations, which could help with observation and conservation efforts. Thank you for attending my presentation. Please let me know if you have any questions.